On your screen, you see a table for the top 10 best golfers not to win a major. All golfers dream of winning that first major, and many this year will be trying to win their first Masters, PGA, US Open, and Open Championship. At the top of my list to win their first major are Zander and Viktor. These guys are middle to early career guys. They've won on the tour, they've finished well in majors, and their world ranking is great, and they've won recently. So I got them about 50% chance of winning a major this year. My 40% category is Patrick, Max, and Tommy. These guys are middle career guys. They've won on the tour. They've been around. Their world ranking is good. So they're thinking about it. Then I got my young guns, Cameron and Tom. These guys are still in their 20s, but they finished well in majors in the past. Their world ranking's great. And so they're my 30% group. And the last group, 20% chance of winning. I got a couple old guys, Tony and Rickie. These guys have been around. They've been close. They're thinking about it. And Will's young guy in his 20s. Same game. He's finished well and he's won recently. They're all trying to win. So from my table, I lean heavily on strong performances in previous majors and world rankings for my first-time major winner predictor. Good luck to all PGA golfers for this year's majors. Welcome back to another episode of Polymer Club's Ask Dr. Paul. Today we're going to highlight polymer shrinkage from processing. So when your boss talks about polymer shrinkage as it relates to injection molding, what do you need to know? Injection molding flows a viscous liquid polymer into a mold cavity, and the part is cooled before ejection. The liquid to solid transformation creates shrinkage in the polymer and part, which must be acknowledged. Let's first discuss processing of a flexible ruler. Is a flexible ruler made of extrusion? And the answer is you could. You could extrude this profile, and then afterwards you could add the details, some kind of pad printing process. But if you look at this specific ruler, you can see the flexible polymer is actually raised. So there's not a profile shape. So this ruler is not extruded, but it is injection molded. And you can tell by the gate. You can see the gate where the material comes in and flows. So for this ruler, we're trying to design a specific part length. So a designer must make the tool longer to account for the shrink rate of the materials. So we want a 12-inch ruler, we want a 12-inch part. So we have to have the tool longer, and then the material shrinks down on cooling to come up exactly at 12 inches. Most property sheets contain polymer shrink rate information to help with these calculations. Tool designers are challenged since amorphous and crystalline polymers have significantly different shrink rates as shown in the table. Amorphous plastics like polystyrene might shrink 3.5 mils or 3.5 thousandths of an inch per inch, and polycarbonate shrinks about 7 mils per inch of length. Crystalline plastics polymer chains get closer to each other, creating high density, and thus they have high shrinkages from the melt. Polyethylene shrinks about 20 to 25 mils, while polypropylene shrinks 15 to 18 mils, since high levels of crystallinity creates high levels of shrinkage. About 20 mils equals about 0.2% shrinkage for these olefins, as shown in the table. Unfilled polymer can also shrink differently in the flow and cross-flow directions. Polymer chains align with flow, called orientation, so you get more shrink with flow compared to cross-flow. Actually, volumetric shrinkage, or shrinkage in 3 directions, can change the shape of your part, which we call warpage. You can see glass filler reduces shrink for the crystalline plastic nylon 6,6. For glass-filled systems, there is increased shrinkage perpendicular to the flow than with flow, which makes sense since the glass rods align in the flow direction without shrinkage, and there is more polymer to shrink in the transverse direction. At some point, we realized many parameters affect polymer shrink rates, including polymer flow direction, additive levels, processing and design. How much the cavity is packed, part thickness, gate number, and gate locations all affect part shrinkage. Many times, property sheets give shrink ranges, and tool builds might start by using the nominal shrinkage values. Moldflow helps predict shrinkage with complex designs, and there is a database of Moldflow shrinkage values for many polymers, when more or less shrinkage is required to hit the part dimensions. If dimensions are of utmost importance for complex parts with multiple thicknesses, the team might measure key dimensions on a prototype tool and apply these values to the production tooling critical dimensions. After all, it takes time, energy, and money to make the best injection molded parts. Knowing the basics of how polymer shrinkage affects tool builds, that's work and knowledge. Remember to like, subscribe, turn on notification, and even share if you appreciate the content. You can visit our website to learn more about our upcoming polymer design course. I'm Paul Nash for Polymer E-Club's Ask Dr. Paul. Thanks for watching.